This lesson is a review on Charles' law and also on standard temperature and pressure. We're going to look at those two things today, and in particular we're going to be looking at a way in which to solve a Charles' law problem. If you remember in the lab when we did a Charles' law, you'll understand that, or you remember that volume is directly proportional to temperature. As temperature starts moving or starts exciting all of those air molecules, let's say within a particular volume, they tend to hit at more regularity and exert more force on the balloon or whatever we're talking about. And so as temperature increases, so does the volume. And that's really what we want to look at today. We'll look at one particular problem and see how that relates. So remember that when we look at Charles' law, it's V1 divided by temperature 1 equals volume 2 divided by temperature 2, which means that as temperature increases, so will the volume. So here's a problem set that we'd like to do. And this one states oxygen gas is at a temperature of 40 degrees Celsius. One of the things you have to understand about Charles' law is it wants it in Kelvin. So when you, and again, I'll show you again, anytime we're talking about Kelvin, when you're going to go from Celsius to Kelvin, you're going to add 273 because 0 is the standard temperature, or excuse me, the standard temperature, and to go to Kelvin, it's 273 more. So it's in this problem, it'll be 40 plus 273 to get to Kelvin. And it occupies a volume of 2.3 liters. And what temperature should it raise to occupy a volume of 6.5 liters? So really what we want to find out is temperature. And that's related to T2. And remember, on this one right here, we're going to take 40 and we're going to add 273 to get to Kelvin, and that would be 313 Kelvin. And then, of course, this would be volume 1, and this is volume 2. And this is what we're trying to solve for, is this volume 2. Now, if you look at this problem, it looks kind of a little bit different than the Boyle's law. And what are we going to have to do with this equation? Well, we have to do a little algebra with it. So we're going to go ahead and cross and multiply V1 and V2 and T2. So V1, and we're going to get T2. And then what we're going to do is going to cross multiply this, and that will be V2 times T1. Now what we want to do, of course, is we want to get this thing right here by itself. So again, using a little bit of algebra, to get that to happen, we have to divide this by V1, and those will cross off, and this will be V1. So if we look at this equation one more time, it'll be T2 equals V2 times T1, all divided by V1. So by the use of algebra, now we can solve for the T2. And if we take a look at it again, we're going to go ahead and plug these in. V2 is 6.5, and that would be, of course, liters. And we're going to multiply it by T1, and that's 313. And then we're going to divide it all by V1. And V1 in this case is 2.3. 2.3 liters. And this is K. So if you multiply these two together and then divide it by 2.3 liters, then what you're going to come up with is 884 Kelvin. Now if we want to go back the other direction to degrees Celsius, we would then actually subtract this by 273. When you do that, you're going to get 611 degrees Celsius. So there you have it right there, either one of these. So in order for it to occupy to what temperature should it be raised to so we can get a volume of 6.5 liters? Well, it's got to go up. So the in this particular case, the volume went up, so the temperature went up. So again, we have a direct relationship between temperature and volume. So let's go, since we've been talking about temperature and standard temperature and pressure, let's just take a quick little review on it. Standard temperature and pressure is sometimes called STP. And when we look at temperature, when we refer to standard temperature, it's at 0 degrees Celsius. And that's the same as 273 Kelvin. So when we go to degrees Celsius to Kelvin, we want to add 273. Now when we want to go the other direction from Kelvin to degrees Celsius, we're going to subtract 273. So when we talk about standard pressure, we're talking about 0 degrees Celsius or 270 Kelvin. One of those two. So that's temperature. Now let's look at pressure. It's a little bit more convoluted, and but it's relatively easy still. Like for instance, for the standard pressure, it's 1 atmosphere, which also equals 760 torr. We're also talking about millimeters of mercury, 760 millimeters of mercury. And then we also have, which is kind of a strange number, but if you want to look at the proof in the math, it obviously bears out, 101.3 kilopascals. So between 0 degrees Celsius and 273 Kelvin and 1 atmosphere and 760 torr, or 760 milligrams of mercury, or 101.3 kilopascals, that's what we refer to as STP, standard temperature and pressure. So as we do more of these problems, you'll need to come back to that. It's best just try to commit those to memory if you can, so you don't have to always look them up. That would be the easiest. So I hope you find that helpful, and we'll be doing a few more of these review problems on gas laws. Thanks.